Sometimes when presented with data, we want to analyze that information in a way that would allow us to detect patterns or to explore in certain areas. It might lead us to question the information in a certain particular way. But it's like we're given a body of information and we just want to look at it and look for trends in the information. Now, the techniques that are used in this exploratory adventure are techniques in exploratory data analysis. And we've looked at one technique, and that's the technique of using histograms. In this segment, we're going to talk about stem and leaf displays, and in a later chapter, we're going to talk about box and whisper plots. Now, the exploratory nature of this, it's kind of like we're getting general information and we want to look for trends or patterns. And contrast that with a kind of analysis where we are directed or we're focused in a certain area where we're controlling certain items within an experiment. And that might occur if we were performing an experiment having to do with gasoline mileage of automobiles. We would identify the automobiles, we would train the drivers, we would make the driving conditions the same for all of the cars, we would identify fuel grades and all sorts of other things. But this exploratory idea is very general in nature, and these are the techniques that are useful in that early on exploratory process. Well, let's talk specifically now about stem and leaf displays, and I can best show you a stem and leaf display with an example. Let's say that we have this information. This information has to do with the weights of carry-on luggage in pounds. And just looking at the information, gee, we can't really see any trends here. It's just a whole bunch of numbers in a particular array. Well, if we rearrange the array a little bit, maybe we can see some trends. And one way to arrange the information is to arrange it by size in particular categories. For example, I see that the smallest weights here, there's a 3 and a 0. I might say, okay, let's put that into a particular category. So I'll come down here and I'll write 3 and 0 together. And then I might think of, well, what about the items that are between 10 and 20? Well, here are those items. I'll put those all together. And what about the items that are in the 20s? And then the items that are in the 30s, the items that are in the 40s, and there's only one item in the 50s, I notice. So I arrange them this way. Well, this is a pretty good arrangement for studying a pattern for these various weights. But we can make this display of the information even simpler to read. And in structuring the stem and leaf display, this is the way we might reason. We might think, well, gee, all of these are 2-digit numbers, and I can think of them as 2-digit numbers, and I can put the first digit, the left digit of the 2-digit number, to the left of some mark like a vertical bar like this. Now, I know the 3 and the 0, those are not 2-digit numbers, but we can think of them as 2-digit numbers if we think of a 0 to the left of each of those digits. So we might think, well, the first digit is a 0, and in the next column 1 is the first digit, and in the next column 2 is the first digit, and then 3 and 4 and 5 for those other groups of numbers. And I'm going through sort of a thought process here of how the stem and leaf display might have emerged as a display form, and how it can be thought of. And this might jumpstart your memory of it when you need to write down a stem and leaf display in the future. Well, we take the idea even further, that if we are listing the left digit in this group of numbers, then we don't need to write the left digit on the right side of that vertical bar. For example, for the 12, 17, 18, 18, 19, 12, and 18, we can think, well, the 1 is already to the left of the vertical bar, so let's take out the 1s and just list the right digits. You see, and now the numbers at the right side are in a simpler form to read, and yet we still maintain the integrity of the information from the data that was originally given to us. And that's the great advantage of stem and leaf displays, is that they maintain, you keep the information that you're originally given to analyze. You see, from what we have written here, we know that 18, for example, appears 3 times in our body of information. We know that because of those 3 8s that are to the right of the 1. Well, let's go through and change all of these rows in a similar way. That is, we'll take the 2's out of the next row, that is, out of the numbers to the right of the 2 that's on the left of the vertical bar. We'll take the 3's out of these numbers, you see, and we're just taking digits out, and we take the 5 out of the 51 and leave a 1. And it turns out that the numbers that are on the left are, each of those is a stem, and the numbers to the right of that vertical line are called leaves. And this then is a stem and leaf display. And normally with stem and leaf displays, you need some kind of indicator as to what the as to how to read the graph, and a way to do that is like this. That 3 with a bar and a 2 represents 32 pounds for the weights of carry-on luggage. So here's our stem and leaf display. And again, this is just the beginning of an exploratory process, and we're able to see very quickly here that the weights that are in the 30s are more often found than any of the other categories. There aren't any weights above the 50s. In fact, we have only one within the group of 50, and it's at the lower end of the 50s. We can see this kind of thing, those kinds of arrangements of numbers very quickly by using a stem and leaf display. Most important thing, though, is that we maintain the integrity of the data. That is, we keep all of the data information in using a stem and leaf display.